Nice. Well, hey folks, like Drew said, I'm Jason, solutions engineer with VMware, and I specialize in how to do CI/CD in the space around Kubernetes, right? So my particular areas of focus are around Cloud Native Buildpacks, right, and running and managing containerized apps on Kubernetes. Yeah, so I know Drew said a bit about it, but I can tell you for me personally, right? Like I don't function well just talking at folks, so I really appreciate questions, interruptions. You know, there's a little bit of this is kind of pre-scripted, and then a lot of it is really dynamic. So we can hop into whiteboards, we can do stuff at the terminal. It's really your session. So I'd appreciate as much interaction as we can get. And I was going to go plug another DC area meetup, but I won't do it since you're recording it. I'll maybe throw something in after the fact. All right, so just to kick off, who here is familiar with containers, Docker containers, OCI images, whatever you call them? Feel free to give like a thumbs up in the chat. All right, that is actually not as many people as I thought. All right, so I'll just step back and talk about containers real quick, right? Like, so containers are a tool for packaging up some application along with its dependencies, right? They're similar in structure to a virtual machine, right? In the sense that you can kind of bundle all your stuff together, but they don't have the same isolation as a virtual machine, right? Or the full set of same constructs, right? A container is really packaging around a process that runs on a physical or virtual machine. Make sense? So Docker came about, right? Like I think 2013, 2014, and really helped popularize containers, right? Which are an older technology. And they popularize containers by making it really simple to start using them, right? So just to show a little bit on my terminal, I've got here a little Linux machine. I can go ahead, I'm running on a Ubuntu Linux. I can do a who am I, right? Now I'm logged in as my own user, but if I do Docker run in an interactive terminal, an Alpine image, right? And I just do a shell. I can suddenly run a shell process on another operating system called Alpine locally on this machine. So I can type who am I, and I'm a different user in a whole different space. Making sense so far? All right, so for those of you that are familiar with Docker, who's familiar with building images with Dockerfiles? All right, I'm gonna assume most everyone. Awesome, thanks. So a Dockerfile allows you to do some pretty important stuff, right? So let me open up a Dockerfile here. I should unclutter my editor. So here I've got a Dockerfile for downloading and compiling a Spring Boot app called Spring Pet Clinic, right? So this is a relatively simple Dockerfile, but it's still an example of what we call multi-stage builds, where we run multiple containers to get our end output of the application we want ready. So we grab a Git repo, we set a working directory, and then we go ahead and just clone, or so a Git container, a container that has the Git CLI, and then we just clone this Spring Pet Clinic repo, right? Then in the next phase, we take another container. Now this container has Java, and it goes ahead and runs the Maven install to get our Spring Boot app built and ready to go. So kind of fairly simple example, right? But we have things like we reference an image base, then we do some transformation, and we take the outputs, and the output is saved as a new image that we can save locally. We can push up to, a remote registry, which is just a store of Docker containers, and go from there. Still all sounding good? All right, so I'm going to go ahead and show you some slides that a friend of mine, Cora Aberclyde, put together for a talk she did at a recent conference around this kind of topic, right? And I'll be happy to send along the actual recording of her talk if y'all want to see it. And she goes into a lot more depth than I'm going to go into. Let me find my little laser pointer, right? So I want to talk about how we're going to build these applications without Dockerfiles, right? So back in 2011, right, Heroku introduced the concept of Buildpacks, right? And Heroku, Cloud Foundry, a couple other implementations are examples of something called a PaaS, or Platform as a Service, right? And a PaaS came about with the idea that, I used to be at a company called Pivotal, and Pivotal used to have this little haiku that we talk about for running containerized applications. And the haiku goes, here's my code, run it in the cloud for me. I do not care how. And the way we accomplished that was our environment, our container environment, could inspect your code, build it into a container, run it on a machine, and then wire up HTTP routing, certificates, logging, everything you need to run your application. And we do it for you. Heroku did the same sort of thing. And the way they did that was Buildpacks. Right? And Buildpacks were great, but there were some real downsides. One, predating Docker, right? They weren't creating images that were in a portable format, right? So a little bit more history, right? Docker came about as the kind of company that popularized making it easy to run and distribute these container images around, right? But they weren't really alone at the time, right? There was another tool competing called Rocket, right, which is also a somewhat popular way to do this, right? And so Docker and Rocket got together in 2013, 2014, somewhere in there, to create a common specification for these containers and for the container registries, the places where we store these containers. That's called the Open Container Initiative specification. The details aren't really important, but the point is, around that time, we established as an industry one common interface for containers, right? And that's that OCI interface or Docker interface. And early generation Buildpacks didn't have that. Later generations did, right? But around 2018, right, a company called Pivotal and a company called Heroku got together and said, hey, look, let's take the lessons we have from the last 7 years of building containers for people, and let's rework it, right? Let's improve on this Buildpack concept and take it so that it's not tightly bound to your runtime environment, right? So they're leveraging that OCI specification to provide standard container images. Okay, making sense so far? There's a couple things that are in here, right? Like looking at the OCI specification, there were a couple places that were ripe for disruption, right? Docker images are great, but that Dockerfile concept's actually fairly old at this point, right? And we found ways to improve that lifecycle around the container, which we're going to get into in a little bit more depth. The biggest one is using Cloud Native Buildpacks. You can share the layers of your container. So let me actually step back a little bit. A container, you look at it, you see it like an archive typically, right? But a container is really a stack of archives, one on top of the other, referenced by a common manifest, right? That describes what's in it, right? So when I go, to show a quick example, when I do docker pull nginx, right? What I see is this is a command saying go to a registry and pull a file, and these layers that you see here on the screen, these actually represent layers of the image itself, right? So my image is made up of a stack of these layers, and every layer it's referenced by like this unique value that identifies the contents of that layer. What we get is as we build images, we can share a lot of layers within a single image, but it's hard to share them between images. So I could build 10 different images on top of Nginx, right? And the only layers they would share would be those base Nginx layers, right? Everything else above that would be unique for every single image. So Buildpacks attempt to reduce the number of new layers that we have to handle and look at, right? Where's my presentation? All right. And then we also have this thing called OS rebasing, which is a much faster way to rebuild containers by leveraging, by essentially hacking that manifest to just replace individual layers when they go bad. So a little bit about Buildpacks, right? When you hear Cloud Native Buildpacks, I'm going to show you a tool to leverage Cloud Native Buildpacks, and there's a bunch of tools to do it, right? But this Cloud Native Buildpack thing that we're talking about, that really only refers to the Buildpacks itself, or Buildpacks themselves. So when you see that Google Cloud has an implementation of this, or Project Tecton has an implementation, or KPAC or PAC have implementations, those are all examples of platforms, right? That build your container images. And these Buildpacks, these are that common tool that can be reused no matter where you are, or what platform you're using, right? They're modular, right? So that means you can assemble them together, and you can write your own. They're an open standard, but they're also part of the Cloud Native Computing Foundation, right? So they were adopted by the CNCF. And in fact, just yesterday, they graduated from a sandbox project to an incubating project, right? So that's just, they're going up the CNCF maturity cycle for projects, for open source projects. All right. You take these Buildpacks and you pair them with two container images, very similar to that from line that you saw in that previous file. Sorry, someone's waiting to get in. Admit. You pair them with two container images, one that is there to do build time tasks, right? That's anything you need for compilation, and one slimmer image that you need for actually running that application. Okay, let's talk about platforms in this Cloud Native Buildpacks ecosystem, right? The thing I'm going to show you today is PAC, and I'm going to show you where to get PAC and get KPAC. So PAC is a CLI tool that you can use just at your terminal, and ideally, those of you that feel like it are actually going to go through setting up PAC and building a container without writing a Dockerfile today. There's KPAC, which is an implementation of PAC that relies on, or that moves that operation from your terminal into a Kubernetes cluster. Uses something called custom resource definitions in Kubernetes to allow you to track and maintain the lifecycle on a lot of images at once. If you're a Spring Boot user, Spring Boot itself has included Cloud Native Buildpacks into Maven and Gradle, so you can actually use your compilation tools to generate a particularly optimized container image for your Spring Boot app. There's a thing called Project Tecton, which is a tool from the Continuous Delivery Foundation. There's a bunch of commercial products out there, including Tanzu Build Service, a tool from VMware. Microsoft Azure has built PAC, or this Buildpacks thing, right into their CLI. And then Google Cloud has a number of different offerings. A couple aren't listed there. DigitalOcean's implemented one, and I'm sure GitLab includes an implementation of Buildpacks directly inside GitLab's Auto Devops. So it's a big ecosystem, and it's getting bigger. As far as Buildpacks, right? We've got the open source Paketo Buildpacks, which are what we're gonna look at today. You have Heroku, the other company that was involved in creating this standard. They publish and maintain their own Buildpacks. Google Platform has their own Buildpacks. They're also open source. VMware Tanzu has some proprietary Buildpacks that you can buy support for from VMware. DigitalOcean also maintains a fairly large library of Buildpacks. And DigitalOcean's and Heroku's are all open source. All right, so we're gonna hop over and actually do some stuff. Jason, sound good? Everyone's still on board with me?
Jason, a quick question. Are
Yeah.
you able to hear me? I mean, when we have this Docker images, right? What is the extra value are we going to get out of these?
Yeah. So what you're getting is the ability to convert your code into a container image without actually having to learn to write a Docker file yourself. On top of that, you're going to get some things around building a container that would actually be fairly complex to implement yourself with a Docker image. And one thing I'm gonna recommend, sorry, not this one. So my colleague Corey Aberclyde has a great course here on Cube Academy that's free. That really goes into depth. So it's over an hour of, you know, how do you build images with Docker files? How do you implement multi-stage builds? How do you get a lot of efficiency out of it? Then she shows doing the same thing with Pack, right? Vishal, I don't believe that AWS has an implementation of it, but they're the only cloud provider that I know of that doesn't. Sorry.
Yeah, sorry for the interrupt. For Vamsi's question, I think it's also, correct me if I'm wrong, Jason, it's also like a declarative versus imperative approach. Like everything in the industry is shifting away from telling machines exactly how to do things, and we're just telling them what we want instead. Like Kubernetes manifest files are just simple YAML files that describe what we want, and Buildpacks are taking that same approach.
Got it.
I'd give you some nuance only in that Pack can work, or the tools around Cloud Native Buildpacks can work in an imperative or declarative way, but moving it into Kubernetes, you absolutely get entirely that declarative way of working, right? It is a way, I'll tell you what you do get, and Drew, to your point, one thing you do get with Cloud Native Buildpacks is you get much more repeatable builds, to the point that every time you build an image using the same inputs in Cloud Native Buildpacks, you get exactly the same output to include the actual hash or the description of that bundle that you've created, right? Which isn't something you can guarantee using Docker files, right? So
Thanks,
anyway,
Jason.
yeah,
Thanks,
no problem. Thank you. So folks, if you can, I'm going to ask that you check out a couple sites here. So I'd love you, if you could, take the time to download the Pax CLI. So I'm going to go ahead and send the link. So this is the Git repository for the Pax CLI. If you head over there, you can go down here to the right to releases, right? Click on releases, and actually I should just send you this link now that I'm thinking about it. Go to the releases and let's do an install of the Pax CLI. So what we're going to do, I'm on Linux, right? So I'm going to use the Linux package, but if you're on Windows, Mac OS, just pick the appropriate value for you. Just do a copy link location. From our shell, we can pop up sudo rm. I'm just going to clear up my old Pack version. All right, and we'll do a curl -lo. So I'm saying curl, please follow, because GitHub does redirects. Please follow GitHub's redirect, and then save me a file called pack. I think it's tgz. Tell me it's tgz. Yes, got it. I got it wrong last night. And then we put down the link, right, to the package we're getting. And of course, you change this from Linux to Mac to Windows, whatever you're going after. We grab it. We do a clear out tar. We're gonna unpack this Pax CLI, right? We're gonna make it executable. Move it in, and if you can do pack version, you're good to go, or pack help. All right, so feel free to follow along, ask questions in the chat or live if you're stuck on any of this, and we can go take a look at it. So now let's just dig into Pack and see some of what's available here, right? Got some commands here. We can build, which is creating a new application. We do this thing called rebase, which is swapping out the base layers in a given application container without modifying the layers above that image, right? So it's a really fast rebuild operation. We have the ability to dig into a given image and look at its metadata, and then we can dig into our build packs, right? So we have the concept of that base image that we call a stack, right? That concept of the build packs, which actually do the job like inspect our code, see what language we're working with, do the compilation, and then contribute the layers that we need to actually run our application. Does any of this sound like something you want to see on a whiteboard for a second, or are we cool to just roll through with a demo? Well, I'll keep rolling through, and then I'll go to a whiteboard later then.
Yeah, I think fine.
I'm sorry.
I think just rolling with the demo would be good. And I think like maybe whiteboard what just happened when we're done.
All right, sounds good. So I'm a little hard of hearing, so I'm not catching everything.
Oh, I'm mumbling. I'm sorry. I'll speak louder.
All right, so to start out, in order to use Pack, we're gonna need two things. We're gonna need source code, and we're gonna need a builder. Okay, so I've got 2 bits of source code. I went and downloaded this Spring Pet Clinic app, right, which you can get right here. I should have had that link available. Spring Pet Clinic. There we go. Oops, I need just the normal Spring Pet Clinic. There we go. So go to the normal Spring Pet Clinic. I'll put that in here. You can just do a git clone and pull it locally and use that. And then we're also going to use this sample repo so that the folks over at Paketo have a number of samples that we can pull. So here's that. Y'all want to see it? And we're going to build a Spring Boot app, and we're going to build a Node.js app, right? And we're going to do the same basic configuration. So let's start out. Let's do pack suggest dash builders. Right. So we're going to ask Pack what are some options that I have for building images. Right. Well, I've got a bunch. I've got a build pack from Google. I've got a Heroku build pack, and I've got a few options from Paketo right out the gate. So we're going to go ahead and use Paketo full, and we're going to do pack. I think it's set default, but let me just check. We're going to do pack. We're going to set a default builder. So pack, set default builder, and we're going to go this Paketo build packs full. So that's going to tell it what do I want to use? What do I want to use to build my images? So now here in Spring Pet Clinic, I'm going to go ahead and build it. Pack build Spring Pet Clinic, and that's it, right? You go look at that Spring Pet Clinic repository. There's no Docker file in there. I didn't tell it what language I was looking at, right? I just gave it a repository with source code, and it's going to build it for me, right? It's gonna automatically give me a multi-stage build. So it's gonna compile this Java app for me, right? Using Maven or Gradle. I'm not even sure which, right? Well, I'm kidding. I am sure which, but I don't need to know in order to do this, right? Then it's gonna put my compiled jar in a slimmed down runtime container that has only what I need to run it. That was really fast. I did this earlier, so it cached it. It normally takes about 5 to 10 minutes to build, probably about 5 minutes to build a Spring Boot app, because pulling down everything from Maven takes a really long time. Nice thing, because I've already built it here, it had a cache, right? So we can look up a little bit, and it saw that it had cached things around how to build this application, various layers that I need for this image were cached locally, and so they just got reused automatically, right? Without me having to specify anything. So I got a fairly efficient build, right? If you clone down that sample app, right? So if you did the git clone samples, you can head in here. You can check out. There's a number of different languages. You know, everything from .NET Core to Node.js, PHP. You can do Golang. Doesn't really matter. We're going to do a Node.js app. So cd Node.js. Check out, they've got an NPM version and a Yarn version. I don't really know enough about Node.js to understand the difference, but in spite of not knowing how to compile a Node app, I can type pack build, sorry, let me expand this a little bit. Pack build, we'll call it my Node app, and hit return, right? It's just gonna produce it for me. So here, back at the top, I can say, hey, listen, let's check out what images I have. Images, grep, Spring Pet Clinic. and I see that it created me a version of Spring Pet Clinic. I use Spring Pet Clinic a lot, so I've got a whole bunch of these images laying around. But I built this Spring Boot app, from source in a way that's entirely repeatable, just with the CLI. Fun bit of trivia: if you look at images built with Cloud Native Buildpacks, they'll all say they were built 40 years ago, which is the start of epoch time for Windows or Linux. I'm not sure which. And the reason they do that is every bit of data you attach to a container changes the checksum value of that container. So in order to make them fully repeatable, the build time is always set statically, right? So it doesn't ever change. Now, as you push these things to your registry, your registry will record what time they were pushed, provided you're using like an enterprise registry. But so you'll have that data about it. So down here, I built my Node app while I was talking. And again, I don't even know how to compile a Node app, right? But we're gonna launch it and we're gonna run it, right? So Docker run. I've got a whole command here. There we go. What I call it my Node app. Docker run my Node app. I can launch my browser again. And I've got a container launched. I've got a container launched that was built with a multi-stage build, in this environment. So that's kind of the key concept. We could do it. We could keep going around with whatever language, and in none of these spots will you find a Docker file, right? Because again, like if I'm someone who writes application code, right? Like I don't actually care about the wiring to get my application built. I care about the business logic that I'm putting into my application. And Cloud Native Buildpacks allow you as an organization to provide a standardized interface for building containers, and they allow you to do it in a way where any improvements you make to the build process, you put into these build packs, and then you share that improved build process contractually with your whole environment, right? So let's take an example. I had a customer, right? They were talking in a meeting about how they were really good at building Flask apps, Python Flask apps in containers. Like listen, like we're way ahead. I don't want to share a build process with the rest of my organization because they don't know what they're doing, right? If they want to transfer that knowledge about how to build the better Flask app, they do what, right? Like go do lunch and learns, talk to their colleagues, maybe submit pull requests to repositories, whatever that may be. But if instead of using Docker files, I'm leaning on Cloud Native Buildpacks, and my organization has a central store for these builders and these build packs, I can build a Flask build pack, contribute it to that central store, and then when I make that improvement with how it's done, everyone in my organization gets to consume that programmatically without having to learn anything about building Flask apps. They can keep not caring, but the whole organization gets that individual knowledge made into organizational knowledge. Make sense? Sound interesting? Sound valuable? Sound boring? Somebody give me a bit of feedback here.
I think it's cool. But
Nice.
I've lived lives where I was the guy writing the Docker files for every application. It's like literally one for one, and it's friggin' torture. I mean, it was especially painful when you had the one hipster who decided to try using this one variant of a Debian-based OS image, and like because he needed some dependency in there, and you literally couldn't port it over onto the CentOS image that everybody else was using. It was torture.
Cool. Well, that sucks, but
I mean, it's better now.
Yeah. All right. Let's see if I've got any more of those slides. I think I lost it. All right. Well, we don't really need the slide deck anymore. So that's our process. A couple other neat things that you get, like some free stuff you get with Cloud Native Buildpacks, right? That you don't see otherwise. I just want to show you this real quick. For those that have an interest in security, I know Judy, that seems to be a strong suit of yours, right? But for those that are in a regulated environment, right? And you need to be able to surface, hey, what's the content of this container? What am I building? What am I using, right? In live production images, right? When I look at something like Alpine, right? So this is the official Alpine image from Docker Hub, right? And I pipe it over to a command to let me take a look at it, right? I can see some data about this container, right? I see when it was created, cool. A little bit of like, what's the command, what environment files or what environment variables did they inject at build time, Docker version, cool, right? But like, this is Alpine, right? APK has a major vulnerability. How do I know if this container has the APK vulnerability? I don't know, right? I'm gonna have to scan it and find out, because the versions of the things that were included in the build of this container are entirely opaque to me, right? My container is a black box, and I can do some after the fact analysis on compiled artifacts, but I don't know what was brought in. I don't know what licenses I'm accepting, things like that. So let's go contrast that with this pet clinic app that I just built. What was it, Spring Pet Clinic? It's a real creative name. Pipe. Yeah, let's just do that. So here we've got our newly built pet clinic app, right? So basically you're seeing the same info, right? Right up until we get to the metadata section, right? And we see just this unbelievable wall of text, right? And I'm kind of scrolling through fast here, but I'll show you this in a JQ statement in a second, right? I've got everything I need to know about this container from what things were included in it, right? This lifecycle metadata down to like what Git commit ID triggered the build. Let's see, where do I get the Git commit? It's just a ton, right? Like everything I could want to know about this image, including every bit about the OSL licenses. Jesus, I didn't think it was this long. Oh, let me just get out. Is just tattooed on my image. So I go run this in Kubernetes, I go run it in Docker Swarm, I go run it anywhere, right? If I want to know what's included, I can just take that inspect info, pipe it over to JQ, and start seeing some neat stuff about it. So let me just grab a JQ query, because I keep a couple of these stored, because I can't ever remember JQ on the fly. Let's go to the bottom here. So I gotta move some stuff out of the way. Oh yeah. Let's grab this. All right, so we can grab, go into config labels, project metadata, and just have, oh, of course that one's empty. Right, I remember this. I ran into this yesterday and I forgot. Just copying and pasting. When I do demos normally, I never type anything out live. I use a tool called Demo Magic to do my typing for me, because I just can't, I can't ever get it right. So here I've got like a bill of materials, right? Just straight up bill of materials about what's in this thing. So if I want to know like what JDK version did I build this with, right? It's right here. What JRE versions is in the running image, right? And everything down to like every other dependent tool and library that got pulled in, right? I get the checksums, I get the open source libraries, right? Like anything I need to provide programmatic data to my security folks, right? So talk about that idea of contracts, right? Like we all want to, DevOps, DevSecOps, we want to talk together better and get better at sharing information, right? Well, like a lot of us stay bad at talking, right? I talk a lot, but not everybody's in that camp, right? With tools like Cloud Native Buildpacks, what we've got now is contractual interfaces between organizations where the data about what's in my image isn't something I have to send over to security. I can just surface it, run a little scraper in my container runner, assumably Kubernetes, pull this data out, send it over to Logstash, send it to Splunk, whatever. And they can write queries. Hey, which live images have a JRE version that's older than 1.1.x, right? Making sense? Right, and that's another thing, in addition to multi-stage builds and correctly done builds every single time, right? You're getting all this metadata on these images for nothing, right? For doing it in an easier way than you're already doing it, fully open source, or if you want, vendor supported, right? You have a ton of options. So if you like, I can hop over and talk about a little bit more about how these images build and just show you that on a whiteboard. And I can talk about what I mean by a rebase, right? Because this is one thing, building your containers is one step, right? But that life cycle involves keeping that image up to date, right? And I'd love to show you a little bit about how you can do that. Sound okay? All right. I had a Docker captain on my meetup last night, and he wasn't super pleased, but ended up getting me a lot of questions, which was nice.
I'm sure that was a little awkward.
No, he loved it in the end, right? But it was, you know, he had to be convinced, right? Because he's been writing Docker files since Docker files were a thing. I'm sharing my screen. All right, folks. So I do a lot of whiteboarding here. So I'm just going to show you another whiteboard example, right? So here what I've got is some color-coded things. So I'm going to talk about stacks, build packs in your custom code, right? The stacks are gray, stacks being that base image, right? The build packs are in green, right? That's that tool to either inspect, compile, or add layers to your code. And then custom code is going to be in orange. Cool. So start with a stack, right? So when we build an image, what happens here is that we actually create two base images, two base stacks, right? Because it's a stack of layers, right? That's what they're referring to. One for build time stuff, right? So here we've got our build image. And one for runtime concerns, right? What's going to actually be in that live running environment? Important difference here is what's actually going to go live to your Kubernetes clusters and what's just going to get stored locally in a cache. Now, so say we're talking about that Spring Boot app that we were just looking at, right? We go contribute some build packs. We evaluate the code. We see, okay, it is a Java app. So we're going to go contribute the OpenJDK here to this image. Then on top of it, we're going to add in Maven. Cool. Those are our build time layers. But we've got runtime concerns. So things like the JRE is in a layer, and the JRE is going to get contributed to that runtime layer. Tomcat, as an example, is going to end up in that runtime image. Now we got your custom code. So your custom code, assuming it's not compiled, although this works perfectly well with precompiled code, you know, it's going to look at that uncompiled code and it's going to put it on that build stack. Then it's going to run the compilation commands and provide anything else that my runtime image is going to need to consume this code. And then our compiled jar comes over here in the runtime stack. Now this here, our runtime stack, that's going to get contributed to our registry and stored and then pulled down and run in different environments. And this build stack here is going to be cached in whatever builder that we have. So with one Spring Boot app, every time it rebuilds, we're going to get some efficiency gains because it's got all these layers cached, right? The only thing that's going to change from Spring Boot app to Spring Boot app is this top layer here, right? That's all that's going to be shipped. That build time stuff is going to stay static, right? Exact same checksums at every layer, right? Which means as you go look at your registry, the same is true for the runtime, right? Only those top application layers are going to be different, right? The layers that the build packs and the stacks contributed are going to be the same. So if you have an image, right? Imagine your images get to a gig in size, and you have 100 images, right? If the bulk of those images are unique checksums, to move 100 images to a registry, you're transferring 100 gigs over the network, right? Or something close to that. Now, take that in a Cloud Native Buildpacks world. All you are transferring over the network uniquely. You'll send that whole 1 gig one time. Then every other transfer is just the unique layers that are going to get moved up, right? So already you're looking at a lot less stuff moving around your network because more things are held true, which enhances that whole repeatability, which is how we get faster builds and faster rebuilds. Still making sense? All right, moving on to the next spot. So I want to talk about what happens later, right? when we've got an image that's in our registry or a number of images that are in our registry and we have a vulnerability, right? Everyone remembers Heartbleed, maybe, right? So Heartbleed was a vulnerability within OpenSSL, right? Which is a really base library that a lot of folks are using, right? That basically everyone uses that serves up web traffic, right? So Heartbleed came out and became vulnerable. And then we had to go around and race to repair our applications so they could maintain the behavior that we had before, but no longer have that vulnerability. A lot of developers had to get spun up to rebuild and retest their apps. A lot of DevOps folks, a lot of security folks. There was a lot of work going into that. Let's remediate this issue. Right now, let's talk about that in a Cloud Native Buildpacks world, right? So as we look at the next version of Heartbleed comes out, OpenSSL goes vulnerable, and here I have an example of one of 100, one of 1,000 images, right, in my registry. They're all sharing these base layers. They've all got OpenSSL, and it's vulnerable to this very serious bug, right? So we need to find a way to remediate it. So with Cloud Native Buildpacks, we have rebuilds that need to rebuild code, rebuild intermediary layers, and then we have rebases where something fundamental, something in the stack is made vulnerable, and the stack just gets replaced. So the way we patch the stack, right, whether that's provided by a vendor, whether it's done in-house, right, the way we patch the stack is we patch it leveraging something called ABI compatibility, which is we take that OpenSSL and we repair it, but we repair it in a way where the binary interface stays the same as the old one with only that bad behavior removed. Right. So what that allows us to do, right? If you're familiar with a Docker image, right? The way you'd replace something like Heartbleed is you'd say, okay, instead of image 1, we're going to do from image 2, and we're going to replace it. And then every layer from image 1 on up is going to get replaced and changed, and you're going to have a brand new checksum every single time. Right now with Cloud Native Buildpacks, instead of doing that, we're going to like rebasing code is where we essentially dereference something in our code stack and reference something new. So we're going to do the same thing. You're going to get provided either by your platform team, by your vendor, by the open source community, a patch stack, right? You'll upload that stack to your container registry, and then you'll trigger that process, that Cloud Native Buildpacks implementation, right? To go ahead and start rebasing images. And rebasing images is literally going into the registry, looking at the manifest file. So there's a little manifest JSON file with every image that describes what layers are in use. And inside that manifest file, we'll say, hey, this layer here that you've got, that's got the old OpenSSL, toss it. Replace it with this layer here that we've uploaded to your registry. Right, and the time it takes to rebase an image in this way is the time it takes to connect a web request up to your registry, modify, do basically a put on a JSON file to modify one line, and then it's done. Right, so I can do a patch on 10, 30, 100, 1,000 images in 5 minutes. When I do demos of this, when I show people, I'll go in and I'll show them patching an app and doing a rebase. And then in the background, I've replaced 30 apps at the same time. And then I show them after that fact. So like, all right, who cares about patching one image? I can patch an image today, right? And so you show that you can do it at scale. So that's what I mean by rebasing. Does this process make sense? I know it's not like crazy straightforward, right? But when you understand a little bit about what is in a Docker file, you can see there's a ton of power here, or the way a Docker container works. There's a lot of power here. Good. Y'all want to see anything else?
I have a question. Thank you so much. This has been very interesting and informative, and I'm very excited to try and use it with what I do at work. Is there a specific way? I know that you said that you use this with Kubernetes. Is there a specific way that it benefits Kubernetes? Because I would assume once you have an image, Kubernetes wouldn't care as much. Is there some extra benefit there, or?
So it benefits Kubernetes in the sense that so I guess the Kubernetes itself doesn't care, but your apps care, because you're going to be able to run and repair your apps much faster. Same thing if you've got a kube cluster, right? Imagine you've got a few different ones in a few different locations. As we get this big vulnerability and we need to distribute those images, right? Using standard image builds, a lot of those layers are unique, right? Using Cloud Native Buildpacks, a lot of them are shared. So when it comes time to patch, you need to pull only that vulnerable layer or that patch layer to your kube clusters, right? Which means less time to pull the image, less bits to pull around, right? Less to actually have as unique data on the actual nodes, right, themselves. So less cache they need to hold. You feel me? So there's a number of ways it works. I'll tell you, putting this tool into Kubernetes allows you to leverage custom resource definitions, which is a big deal, right? So Kubernetes, just to go on a quick tangent, Kubernetes is really powerful because it's a big desired state reconciliation engine, right? Which means basically I just say what to do and it does it. And it doesn't just do it once, it keeps doing it forever. Like every 2 seconds, it's trying to do that thing that I told it to do, 6 months ago. So if I register 100 images with a Kubernetes cluster and tell it, yo, keep these images up to date, Kubernetes is keeping them up to date like every couple of seconds all the time. So as I do that thing where I say, hey, listen, update this stack because my old one was bad, I need it patched. Right? Kubernetes is going to go through and be like, oh, awesome, work to do. Let's go patch all these images and let's do it right now. And no one had to remind it. No one had to go bug your developer and be like, yo, dude, can you please do a git commit so we can get patched, right? Instead, it's just, nope, you're patched. And the CI, right, that continuous integration gets you an updated image artifact into your registry. And then you can hand off to whatever your delivery process is to validate that image and say that it's good to go in production. Did I answer your question, Rachel?
Yeah, that makes sense. Yeah, all my work is with Dockerfiles, Kubernetes, and that whole pipeline. And so, yeah, I'm very excited for this to speed up everything to getting it out.
If you want to see some examples, it's pretty easy to integrate. If you already run a CI system, it's pretty easy to integrate with a CI system. So let's see, what do I have? I need to find which window to pull up. So I've got a little CI server. Oh, it's broken right now. But in my CI server, right? Like I take source code. My CI server monitors the source code, runs a test, so a Maven test, goes and runs a Maven build. So ignore the failed one that just happened. It runs a Maven build, right? So my last one didn't build, but that's life. It compiles the code and then it hands it off after it does the compilation. It hands it off to an implementation of this Cloud Native Buildpacks, where I get this inside Kubernetes, this detect, this analyze, what have you already done? Go ahead and build this image again, right? Hands it off now to a cluster repo, right, where I can store cluster config, right, where I store the configuration, right? So this is the state of the app that I want to see in Kubernetes. So it updates the manifest file and changes out the image reference from one value to another. Quick side note, while I know we're about at time, but I just want to put this out. If you're using Docker images, there's what you usually see, like when you see like latest or version 1, 2, 3, whatever it is, that's a tag. So that tag is actually, that's for humans, not for computers, and it's actually mutable, right? So that means it can change. So when you're referencing images, especially in a production environment, reference them by their checksum, which will never change no matter what happens to that image. So you can't have something slip into the environment, right? Well, so it ends here. It updates this cluster repo, and then my continuous delivery kicks off and slips it in. But whether you're using whatever CI tool you're using, where you can integrate with a Cloud Native Buildpacks implementation, right? And like I said earlier, right, like GitLab CI already has an implementation where it uses this natively, and you can see an example of integrating it with a Kubernetes-based implementation of Cloud Native Buildpacks, actually from the last VMworld. All right, sorry, that was it. Didn't mean to run long, Drew.
Can I ask one more question?
Please do, yeah.
Can you run Pack within Kubernetes, or do you have to work with Docker and that whole mess?
Yeah, so the Pack tool itself requires Docker, right? So you'd have to do Docker to run Pack natively within Kubernetes, right? That being said, when you use something like Auto DevOps from GitLab CI, they've already set up the Docker interface. And then when you hand it off to a native Kubernetes integration like Kpack, which I had pulled up a minute ago, but let me just pull up Kpack again. So again, this is open source. I don't actually need to sign into Pivotal to get here, but oh shoot, I'm gonna have to do some stuff. Give me one sec. But when you go to the Kpack repo, you can actually just download, apply a given release file, install it to your Kubernetes, and then integrate that with your CI system. So you can do the build via whatever your process is, and then handle the actually creating the container over to a kube cluster. Sound good? All right, I'm hoping that answered your question.
Yeah, it definitely did. Thank you. Yeah, I'm curious as to how it works under the hood, you know, detecting everything. I guess it looks through requirement files and all the dependencies and just aggregates those and does what it needs to.
So that's explained in a ton of depth when we go into the individual build packs, right? So, and these are all open source, so you can just go check them out, right? So they've got a couple of interfaces inside the build pack, and they talk about it a lot here, and they talk about it a lot here at buildpacks.io, and they'll actually walk you through creating your own build pack if you want to see it. So let's put this in the chat, buildpacks.io. So this is the site for the official CNCF project, and this is the site for a given and fairly popular implementation of Cloud Native Buildpacks. All right, let me stop sharing.
Cool. That was awesome.
Cool. I'm glad you liked it.
Have any other questions, comments, concerns for Jason?
Yeah, one question, Jason. I'm not sure it is the right question, but so the Docker images has always like issues with the security, like security. It could have a lot of issues because if we are not hardening it properly, it will have some open holes, right? So does this particular build packs helps any way to make it simpler to harden the image?
Yeah, so it does some things by default, which are going to give you more hardened images than if you're building off Docker files. That being said, right, like the responsibility for hardening those base images is still something that needs to be handled by either you, a vendor, or the open source community. So it does some things that are more secure than standard Docker files by default, things like multi-stage builds, or making it simpler to keep your code patched and up to date, right? But it doesn't solve your security problem in and of itself. So short answer is yes, it does some things, but it's you don't lose all those concerns, right? And the team that is responsible for the maintenance of Docker images still needs to be involved in that process.
Okay, thank you.
Makes it easier to do the right thing.
That's correct. Yeah.
Right. Okay.
Right. So with Cloud Native Buildpacks, you're going to build your image the right way, and you're going to do it without having to learn a bunch of stuff about how Docker works.
Cool. Any other questions, y'all? All right, we'll call that the official end